So my name is Krishna Milnathar. I'm an assistant professor here at Ashoka University with a joint appointment in the biology and psychology departments. We study sleep and plasticity using the fly Drosophila, and we're primarily interested in a couple of different aspects. One is how does sleep actually promote plasticity in learning, and the second is how is sleep itself plastic, how it's modified in response to different kinds of challenges, different kinds of things that a fly might encounter during its life, and so on.
What is sleep?
It's not actually an easy thing to define at all, because at a very, at a fundamental level, like an elemental level or molecular level, we don't have an understanding of what sleep is.
Sleep has types or categories.
Only us humans who sleep, so I should, re-emphasize that, because not everybody is necessarily familiar with this idea. But really, it's a picture that's changed a lot in the last 20 years or so. So, about 20 years back, it was a very kind of human, meaning-centric view of sleep. And that largely came from our own personal experience, right? Because you have this very vivid experience of, falling asleep and coming out of sleep. Pretty clear that pretty much all animals sleep. Even with 300 neurons, you can generate sleep. Humans, we can differentiate non-REM sleep into different stages. So, for example, babies will have a lot more REM sleep. They sleep a lot in general, and then the proportion of REM sleep is also higher. They tend to spend a lot of time in bed trying to sleep, obsessing about sleep, but not getting it. So instead, what they say is you restrict your opportunity. Say, I will give myself only this time to this time. So if I wake up, get up, go out. Amazingly, this CBTI seems to work even in the fly. Okay?
What type of sleep is important?
REM sleep is also very important. Very interesting things are happening in REM sleep, and you don't get as much replay, but you get a lot of dreaming. And REM sleep seems to be particularly important for creativity. For example, if you give people a bunch of words, a doctor, a nurse, stethoscope, ECG, and so on, everything except the word hospital. People that have, if you disrupt REM sleep, for example, they don't do so well at that just word.
Who dream a lot? They are creative people.
Right, creative people maybe can put things together, put disparate pieces of information together in interesting ways.
So there is something called deja vu.
And the woo, I think it's people who have sleep apnea are unable to breathe well. So if you have really severe apnea, if you snore a lot, don't ignore this at all. Humans, they try this drug, and then it seemed to induce hallucinations in recovering drug addicts in a clinical trial. So they pulled the drug, Merck pulled this drug from the market because of that problem of, hallucinations in drug addicts. Thankfully, our flies are not drug addicts, so we're okay. But
I am deprived of sleep, or a good sleep rather. Over a long period of time, my mental health is also going to be affected severely.
absolutely, your mental health is going to be affected. You're going to make poorer decisions.
Early to bed, early to rise makes an unhealthy version. Is it true?
No, probably not.
How is it? Is emotion has a role there?
I don't think there's much evidence for that.
Thank you, sir, for your time, and thank you for agreeing to come onto this platform. It's a pleasure to have you in my this podcast show. So today, our discussion primarily, as you are one of the leading scientists in the field of sleep and sleep research, precisely.
Yeah.
Sleep is something I think everybody knows what sleep is,
Yeah.
and
I think they know, but maybe they're missing out on a lot.
right, that is where we will try to understand from you
With
in the very simple generic way that first, what is sleep, what are types of sleep, what our might be day to day, people might have questions regarding sleep, and all those questions I try to position it as Hemant is here.
Great.
To start with, sir, what is sleep and how it is important for our body?
Great. Thank you, Somenath. So happy to be on this platform, and really excited to chat. So sleep is, of course, something we're already familiar with. It's a state we enter into and exit from, every day. So it's very familiar to us from our daily experience. But maybe if you pause and think about it a little bit, it's not quite as easy to tell what is actually sleep from, other states of unconsciousness, like, for example, going into torpor or a coma or something, right? Or which are states of suspended consciousness, but they're not sleep, right? So sleep you can define. It's not actually an easy thing to define at all, because at a very at a fundamental level, like an elemental level or molecular level, we don't have an understanding of what sleep is. So there's no simple molecule or cellular phenomenon you can look at and say that's sleep, right? So instead, what we have is a bunch of correlative evidence, and so the more correlative evidence you have, the better, the stronger your belief that it really is sleep. So, for example, there are a lot of behavioral criteria which are used to define sleep. Primarily, there's four criteria. One is, of course, that you have to be immobile for a period of time, right? But of course, it's not sufficient because you could be paralyzed from not moving, right? So, how do you distinguish sleep from paralysis? So, sleep is that comes to the second criteria, which is that it's rapidly reversible. It's a rapidly reversible state of immobility. So, if you stimulate the person, the animal, hard enough, it should come out of sleep very fast, right? Uh, uh, um, as opposed to paralysis and so on. It's have more, right? But even that is not sufficient because, for example, how to distinguish sleep from just quiet waking, that is sitting quietly and not moving, right? And contemplating about the universe or something, right? So do that, you have this third criterion, which is that it's associated with heightened arousal thresholds. Okay. So that means that you have to be harder to rouse when you sleep. That once you stimulate the animal more, the person harder to rouse the person or the animal from sleep, right? And finally, there's the last criteria is that it's homeostatically regulated, which means that um, if you deprive the person or the animal of sleep, the next day you should see a rebound or uh, uh, you sleep more, you sleep deeper to make up for the sleep that you lost.
So that's sleep inertia, which we say.
Right. So sleep inertia is like different phenomenon. Sleep inertia is this ability to not come out of sleep quite so easily, right?
Okay.
But which is also an interesting phenomenon, but slightly different. But rebound sleep is more that if you lose sleep the previous day, the next day you sleep more, you sleep deeper, or both to make up for that lost sleep, right? And then finally, of course, many animals will also show a specific sleeping posture and so on, right? And then uh, the- in addition to these behavior criteria, there's also, of course, frequently brain, neural activity associated changes, with sleep as well.
So basically, sir, compensating for the loss of sleep which I had the previous day, the rebound sleep is actually compensating for.
Correct. That's right. That's right. Okay. Yeah. In some ways, making up for those, sleep functions that you missed out on when you was thinking about it. All right. Yeah.
So sleep has types or categories.
Right, absolutely. So, there's two broad categories. So, first of all, it's not only us humans who sleep. So, I should, maybe, re-emphasize that because not everybody is necessarily familiar with this idea. But really, it's a picture that's changed a lot in the last 20 years or so. So, about 20 years back, it was very kind of human, mammalian-centric view of sleep. And that largely came from our own personal experience, right? Because you have this it's a very vivid experience of falling asleep and coming out of sleep, and it happens every day, right? So it feels very it's very personal to you, right? And so I think because of that and this association of sleep with consciousness and all of that, and there's a lot of philosophers that have theorized about sleep and so on. So I think because of that, it kind of led to a little bit of a human centric view, right, of how of what sleep is. And but in the last 20 years or so, 25 years, I'd say, this pattern has really dramatically changed, and now it's pretty clear that pretty much all animals sleep. Okay, or at least all animals that have a nervous system get sleep, right? And so, but clearly they're very different looking. They have a nematode worm which has only 300 neurons versus humans which have billions and billions of neurons, right? So you know even with 300 neurons you can generate sleep, right?
Yeah.
And so coming to a question about different kinds of sleep, broadly there's two broad kinds. One is called rapid eye movement sleep or REM sleep, and so this was first discovered in human infants in the 40s by Nathaniel Kleitman and colleagues, and Eugene Aswinski at the University of Chicago. So what they found was that there was this stage of sleep that was associated with these rapid eye movements. Right, so eyeballs are moving, and actually, if you look at the brain looks like it's active.
Oh.
Okay, so it's also called active sleep, sometimes called, so Kleitman and Azinsky called it paradoxical sleep because the brain looks like it's active.
Yeah.
So if you look at the brain activity patterns, EEGs, so-called electroencephalograms,
Yeah.
it's lighting up. So brain's like it's active,
Okay.
but and then you have this what is sometimes called quiet sleep or non-REM sleep, where the brain activity is overall lower, um, although this brain is still very active even in non-REM sleep, um, and processing information and so on. Uh,
So grossly, if I say, these are the two categories.
These are the two categories, and in humans we can differentiate non-REM sleep into different stages. There's three broad stages now.
Okay.
1, 2, and 3.
Okay. So is there any pattern, like if I go to sleep now
Right.
and the first REM sleep time, because that time my mind is fully active, although I'm sleeping, my eye movement is still there.
Right. So typically that's true. So there's a sleep cycle in humans,
Uh-huh.
um, and we cycle through these different stages. The cycle lasts about 90 minutes, roughly, and so we'll actually go into non-REM sleep first. The first stage of non-REM sleep. When you fall asleep, you go to non-REM sleep. But typically, when you wake up, if you're waking up without an alarm clock, by and large, if you wake up spontaneously, you wake up from REM sleep, not non-REM sleep, right? So you start with non-REM sleep, and then the proportion of REM and non-REM changes through the night. So you get more non-REM in the early part of the night, early and middle part of the night, and towards the later part of the night, you start getting a lot more REM sleep.
Okay.
Towards the early morning when you wake up.
Right. So there's like patterns there for every individuals, more or less we can do, or it is like a random process.
More or less similar between individuals. It changes with age, of course. So, for example, babies will have a lot more REM sleep. They sleep a lot in general, and then the proportion of REM sleep is also higher in babies. Um, and then you stabilize at this kind of young adult pattern. And as you age as well, there's a lot of sleep abnormalities. You tend to wake up a lot more, spend less time in non-REM sleep, and so on. So sleep becomes a lot more fragmented and things like that. Yeah.
Okay, okay. This like a circadian rhythm is also something which somebody can, like, if I practice certain amount of going at a right time,
Right.
at a fixed time, and then I try to wake up at a fixed time and make it as a habit. My body's clock actually behaves that way.
Absolutely, absolutely. So that's one of the things a lot of sleep clinicians really emphasize is to try to maintain a regular sleep schedule, or find a regular time to go to bed and wake up and so on, and that really helps. Uh, and in fact, even with insomnia, there's very interesting, behavioral therapy for insomnia in humans called CBTI, or cognitive behavioral therapy for insomnia.
Okay.
And so this is a set of behavioral modifications to try to help insomniacs. But one of the interesting things there is this concept of actually restricting sleep opportunity.
Okay.
Okay, so it's somewhat counterintuitive because you think I'm having trouble sleeping, I should be in bed. Okay, but actually, what actually helps is the opposite. Okay, so what actually helps insomniacs is restricting your opportunity to sleep. Okay,
Okay.
so that means you say bed is only for sleeping, and I'm gonna if I'm feeling from kind of getting awake, you know, then don't be in bed. So a lot of insomniacs will instead spend a lot of time in bed trying to sleep, obsessing about sleep, but not getting it. So instead, what they say is you restrict your opportunity. Say I will give myself only this time to this time to sleep, and the bed is only for sleep. So if I wake up, get up, go out, do something else, come back, and then
Okay.
try to get to bed. Right?
So basically, I'm tuning my brain.
Yeah.
When I'm on bed,
Right.
I should be sleeping.
Right. Right. Right.
Okay.
Right. Yeah. And actually, very interestingly, one of our colleagues, Matt Kaiser at UPenn, had shown that even Drosophila, which we work on, amazingly, this CBTI seems to work even in the fly, hey? Which is really, I think, pretty mind blowing, and maybe mind blowing for a lot of people who never think of the little fly with a few 100,000 neurons, as being something capable of complex cognition and so on. But here you have this this technique that came straight out of human psychology, right? And you can try and fly. Of course, in the sector of fly sleep opportunity, you currently sleep with silent bed. But what you can do is change the light dark schedule, right?
Yeah.
So you have, say, instead of we keep flies typically on a 12-12 light dark schedule. But if you lengthen the day a bit, then you kind of restrict the opportunity, right? So you say only 10 hours at night, 10 hours at dark time, or 8 hours of dark time. Then the sleep, even flies that are insomniac like, right, that have trouble going to sleep, trouble staying asleep, and so on, it helps them. Right? They sleep more, they sleep in a more consolidated way, and so on.
Yeah, yeah. I think rightly said. Actually, when I visit some animal houses,
Right,
in animal houses, because most of the mice and rats are they're nocturnal.
right. That's right.
For them, like if you have to feed them in the night, it's a big no. So what they do is they use a red light and
Right,
flying towards red light.
right,
So apparently it's a dark phase or a period for them.
right,
And being nocturnal, so in the night time they use only red lights.
right. Absolutely.
Right, because they are active when it is dark.
Right, exactly.
Unlike us.
Right, inherently.
If you light up somehow, there's a bulb in the room, there's a light.
In the daytime, they use red light. Not in the night.
Not in the night.
In
In
the
the daytime, if you have to go and so there is a red light there.
the daytime, probably. The nighttime, probably.
No, actually, they're blind to red light.
Right.
So, as they're blind to red light,
Right.
in the night time, you have to maintain the darkness. So, red lights are not able to see.
That's right.
Right. So, whenever I went to animal houses, they say in the night time, like from 6 to morning 6, it was the red light.
That's right. Yeah, we do that too, a little bit too, because flies also blind to red light.
Yes.
Yeah.
So, I had been to NCBS, I'd been to animal voices.
That's right.
They practice it, and it was really interesting for me also to see that how this simple psychology of light and dark is actually inducing. So the breeding of the animals, the health and the behavioral changes are huge if we just change the duration of light and dark.
Absolutely.
Yeah, that's reminded us sort of.
Cool. That's really cool. Yeah. Some of the work from our lab was also, for example, we were able to show that if you took some of these these flies that are short sleeping, they don't learn so well. But again, if you restrict their sleep opportunity, can improve their sleep and actually restores learning. So the sleep is actually helpful.
So time to this point not there, because my next is like how sleep or what type of sleep is important for learning. So basically the cognitive response of the brain improves.
Yeah, that's great. So actually, both kinds of both stages of sleep are important, and they serve slightly different functions. So in non-REM sleep, for example, um, where classic work had shown this phenomenon of replay, okay, which was classically shown by Wilson McNaughton, where they trained rats, to run along this track. You sprinkle a piece of chocolate, to motivate the rat, and the rat will just run, right? And then they started the recording from this part of the rat's brain called the hippocampus, which is a part that encodes space, right? And what you see is that this hippocampus lights up as it's running, but the interesting thing is when it's sleeping, it's replaying this experience. Okay, so you see the same sequence of activation of these so-called place cells replayed at night. Okay? But it's a kind of fast-forward replay.
Okay.
And that's associated with non-REM sleep, and there's this kind of with a specific state, something called sleep spindles, and then you see this kind of dialogue between different parts of the brain. There's a part of the brain called the hippocampus, and there's another part of the brain called the cortex, which is this big structure that sits on top of the hippocampus.
Yeah.
And so you have this dialogue between the hippocampus, the cortex, and the hippocampus, fires, and then the cortex will fire, and then the hippocampus will fire back, and so on. So there's a kind of dialogue, and this dialogue is really important to consolidate that experience into a memory.
Right.
So if you disrupt this dialogue, disrupt the spindles in some way, they don't remember so well the next morning. Right? And also another interesting phenomenon during non-REM sleep is something is something called brain clearance. And so this was an idea from Michael Newgart's group about 10 years back, which is this idea that um, somehow the brain is clearing out these toxic metabolites. So during waking, normally, you get neurons are firing, and the idea is that they accumulate some of these toxic metabolites, and these things are cleared more during sleep than during wake. That happens during non-REM sleep primarily, right? Um, and then during REM sleep is also very important. Very interesting things are happening in REM sleep, and you don't get as much replay, but you get a lot of dreaming in REM sleep. And REM sleep is particularly important for for creativity. And so, for example, if you had so memory is really about, we asked what's memory for. Memory is really about remembering exactly the events of the past, right?
Yeah.
And that's great. But the brain does a lot more interesting things than simply recollect exactly what happened in the past, right? You also put that information of the past together in interesting ways, right? To try to extract information that is not exactly what happened in the past, but related to it. So, for example, um, there's this phenomenon of gist extraction, which is if you give, for example, if you give people a bunch of words, let's say, doctor, nurse, stethoscope, ECG, and so on, everything except the word hospital, right? So with a bunch of words are related to it, but not that exact word, right? Um, and then you find that again, the people that have, if you disrupt REM sleep, for example, they don't do so well at that gist word. Right?
Okay.
So that extracting that gist is also an important thing.
Yeah.
The brain does.
Yeah.
Very interesting, interesting ideas as well.
So, like, they are not comprehensively see the entire, no, the summary of it. Is it like?
Yeah, it's able to extract. The brain is extracting that gist. From, so it's not remembering. So there's a question of remembering exactly these words, doctor, nurse, stethoscope, and so on. But there's also extracting that. What's the summary? What's the thing that links these things, right? Um, so those are kind of interesting things. And
Because people who dream a lot, they are creative people.
right. I mean, I think creative people maybe can put things together. Put disparate pieces of information together in interesting ways. I don't think they necessarily dream a lot, but I think dreaming certainly helps with that. Um, and there's this kind of apocryphal story about Edison that he used to like he was this very inventive guy, right? And come up with different things. And he had this idea that he would sit like this, and holding up like a ball with a little metal thing at the bottom, and that and then nod off to sleep. And then when his hands, when he fell asleep, his hands would relax. The thing would fall a little down, right? And then so this is his way of kind of recollecting his dreams in some way, and he would jot down whatever was going on in his dreams, whatever. So so yeah, I think dreaming is an interesting state.
Yeah. But
Yeah.
so when we see a dream, all of a sudden we wake up, like, due to any event.
Right.
We remember it for a very short duration, and then that goes away. Why is it so?
Right. That's a good point. I mean, in some ways, it's not a bad thing for it to go away too, because you're not remembering. Again, the idea is not to if you would think of what's the benefit of dreaming, right? And so it's not to it's not, again, it's not to remember exactly events, right? It's to get presumably the benefit of dreaming is some kind of creative insight, something you get some gist out of it, right? And think and so you don't need to remember exactly the events of the dream. So one very interesting idea I read about dreaming was that and REM sleep is, so it's not about a replay of the past. It's more a sort of pre-play of possible futures. You know, so kind of it's like brain putting together a piece of information from the past in ways to kind of think about what might become.
Wow,
Right.
that's interesting point.
Yeah.
And coming to that only, I was reading somewhere. So there's something called deja vu. Is it the same, or something is in the future is going to happen, and you in the dream you're able to see something up a glimpse of it? Is it has it scientific
There's
background?
deja vu. I mean, I mean, I think it's, you know, clearly things are, you know, you it may be related to a dream you had. That would be an interesting idea to look at whether deja vu is related to some kind of, a dream you had before.
I just want
Yeah,
explore because
yeah, there would,
all of a sudden you see certain flashes
right,
and the next day it happens. And when it happens, you feel like, oh, I already saw this.
right, right. It's true. I mean, but you probably just, that might be also somewhat selective in the sense that, you probably did many things that didn't happen, and those things you don't necessarily, remember, don't necessarily highlight so much or something. But it's only the ones that do happen that kind of stick out. Um,
So then coming to like sleeplessness, some people are not able to sleep. As I
Right.
said, the opportunity has to be restricted.
Yeah.
In that light, is sleep apnea or insomnia? Is it a disease we can classify?
Yes, so sleep apnea and insomnia are slightly different things, but sleep apnea is a very debilitating disorder. And it's particularly debilitating because, the people who have sleep apnea are unable to breathe well. So if you have really severe apnea, if you snore a lot, don't ignore this at all, right? So it could be a sign of a serious breathing disorder. So please, get it looked at, right?
Yeah.
Because it can really lead to pretty bad outcomes, right? And so what helps with sleep apnea is really what they call continuous positive airway pressure, CPAP. So they give you a little, a little pump or a device thing they can put over your mouth, and the thing actually, pumps, right? Gives it continuous positive pressure to kind of help with the breathing. And a lot of times people wake up from, apnea, wake up because they're unable to breathe. Um, um, so, so it's always a protective thing.
Yeah,
Yeah,
I think it's good that if we are aware right on we need some medical help, we should
right,
definitely getting it checked.
right.
But coming to say like there are a lot of medicines are also there which helps you to fall asleep. So is it a good practice to assist with the help of medication to fall asleep, or with our little bit effort, maybe our lifestyle changes, should our circadian rhythm be set? We can do
Right.
the setting.
Right, absolutely. So, the problem is a lot of sleep medications, they really don't have a good, there are a lot of side effects and so on. So, this is a huge problem. So, we've really not been able to develop a good pharmacological agent that can modulate sleep without these other problems. In humans, in flies, we have this great drug. It's called gaboxetol. It's a GABA agonist. Puts flies to sleep. It does great. But in
And then side effects.
they have no apparent side effects. They live long. They do great. Have great memories. It restores memory and all. That's fantastic. Yeah, it's a wonder drug for flies. But for humans, they tried this drug, and then it seemed to induce hallucinations in recovering drug addicts in a clinical trial. And so they pulled the drug. Merck pulled this drug from the market because of that problem of hallucinations and drug addicts. Thankfully, our flies are not drug addicts, so we're okay. But yeah. So in general, I'd say uh, yeah, that there are simple things that people usually recommend if you're having trouble sleeping, just following a regular schedule. A lot of times there are work pressures, also social pressures, and so on. So people tend to stay up late on weekdays and try to make it up over the weekend, but doesn't work, right?
Yeah.
So you have the so-called social jet lag. So that doesn't help. So try to maintain regular schedule. That always helps. Keep your room cool and dark as much as possible, and so on. Okay. Uh, yeah. So these are kind of
So
the things that can help.
when I am having a good sleep, the morning when I'm waking up,
Yes.
so automatically I feel fresh,
Yeah. Absolutely.
right? So is that an indication of a good sleep,
Yeah. Absolutely.
right?
Absolutely. Absolutely.
Okay, and during sleep, with my little bit of understanding, what I understand is, like brain also does a lot of its pruning, and as you said, the clearing part.
Right.
So,
Right. Absolutely.
right. So what we do is like on day to day work, we knowingly, unknowingly collect a lot of informations.
Mhm.
We have to decide what to be retained and what to be cleared of.
Right.
So that happens during sleep.
Yeah, actually brought up some great points there. We can talk more about that. So one was this what you said pruning. So this is another interesting idea about functional sleep that actually maybe didn't bring up so much, but um, this is an idea of course synaptic homeostasis put forth by Schiaccia and Gino Tononi about 20 years ago. At least they codified it anyways. This is the idea that during waking, you're out there experiencing things and, so on, constantly getting stimulated. And this leads to more and stronger synapses in the brain. And that during non-REM sleep, particularly, these synapses are paired back. Okay. Um, and, and so there's a lot of evidence in favor of this. For example, in many animals like rats and flies and so on. So on average, that's probably true. I think that's almost certainly true. Right? On average, you get less synapses during sleep, more during waking. Right? But uh, but there are certainly very important exceptions. Oh, so for example, there are parts of the brain that are important with learning and memory and so on, where actually you get more synapses, stronger synapses during sleep rather than during waking. Right?
Okay.
So then, the way the field is at now is really arguing about what is more important. Is the average important or is the exception important, right? So that's what everybody's really arguing about. And we haven't quite resolved that yet.
But when you say an exception, that means it is not a general norm.
Yeah, so on average, it's true. If you look across the brain, on average, there are certainly fewer synapses during sleep and more during waking. I think that's almost certainly true,
Okay.
right? But then, of course, the question is what's really important? Is the average important? Is the exception important? And so on and so forth.
So acceptance, there are any like stimuli or any conditions because of that they are following a different pattern?
Well, that's a good question. See, a lot of circuits involved in learning and memory and so on suddenly get strengthened. So, for that comes back to when we were talking about replay. So it's not really an external stimulus; it's an internal stimulus. So you're replaying that experience during sleep. That's an internal stimulus, and that is actually turns out it's a replay of these place cells in the brain. There's also a replay of visual neurons and so on. So it's like you're literally seeing in your sleep, you're literally seeing, what you had experienced before. But this question of what gets retained and what doesn't is actually a fascinating question. And I think that's really where sort of sleep science is going a little bit. We're just trying to figure that out a little bit. How do you prioritize? How does the brain prioritize?
My question is
One versus another. Yeah, we experience a lot of things. That's what I don't quote all of them, right? Yeah. Right. Some because how does I'm sitting here in this prioritize this? Yeah, I'm sitting in this room. There's my office. There's a few tents. There's some things around you and so on. You don't necessarily prioritize all of that. I'm talking to you. You're the most sane person. I don't remember all these other things around it, right? Even though you're getting the same visual input. Absolutely. So that's really an interesting question.
so actually in one of my previous podcasts I was having with Professor Tony from Ames. So he was telling the same thing that right now I'm talking to you, and you see that a lot of sounds are there. The ripping of the machine,
Right.
there's somebody walking in the corridor.
Right.
Very good to hear them.
Right.
But when I'm talking to you, my entire focus of the brain is putting an effort to focus at your expression.
Right.
And my body is trying to mimic your expression.
Right.
And even the way I'm speaking, my voice, pitch, and everything, actually trying to do focusing onto you. Yeah, this is the smartness of the brain
Yeah.
that without damping or without being biased towards things, it is giving you that attention ability.
Right, right, absolutely.
Right, sir.
Yeah, so that's a great question. Certainly, it's subject to much ongoing research now. It's trying to figure out, in some ways, I guess, a different way of putting it is how does the brain tag different experiences? So some experiences get consolidated, some don't. Why is one experience tagged and the other not, and so on. Some of that is probably related to emotional salience, for example. Some of the things that are more emotionally saved get tagged, seem to get consolidated more stronger. But that's not all of it. And trying to figure that out is a very interesting question.
Yeah, yeah. Another, maybe just out of you said emotion. So some people are inherently more emotional expressive, others are not. So people who are more expressive, do they have a particular, like, this during their sleep, in the REM sleep precisely, they have more, this replace goes on, or how is it? Is emotion has a role there?
I I don't think there's much evidence for that. But certainly, I mean, sleep will affect your emotion the next day. If you don't sleep so well, you're cranky and so on, all that. But I'm not sure that individual differences in emotional expression are necessarily correlated with sleep or distinct differences. I don't think so.
Right. Sir, I think in Japan these days, the corporate life had been so exhaustive.
Right.
In their offices, they have made a make and shift beds.
I know, and it's crazy. It's crazy.
So that's,
It's a little extreme.
and if you see there, the rate of reproduction, their overall health has deteriorated. So
Yeah.
government is telling you should sleep.
Yeah, yeah.
So that means sleep is that important, right?
Yeah, absolutely, absolutely. And mental health as well is a huge problem in Japan and so on.
Yeah, yeah. It has been in the news recently.
Yeah,
So when I was going through it, then I said, okay, very soon I think India is also following that footstep
yeah,
with the corporate culture.
yeah, absolutely. Particularly in high finance and so on. There's a lot of problems that people have to stay at work for crazy hours, 100-hour weeks and so on. Yeah.
True, right?
Yeah.
So I hope that doesn't,
Yeah, maybe we don't have good strength. Hopefully, we don't go down that path.
yeah,
Yeah.
yeah. So that means if I am deprived of sleep, or a good sleep rather, over a long period of time, my mental health is also going to be affected severely.
Really, absolutely. Your mental health is going to be affected. You're going to make poorer decisions. And even for corporates who might be listening, it won't necessarily help your bottom line in the long run, right? Um, it's going to help you in the short term, but it's not going to help you in the long time.
So your overall, I also believe if I am not fresh in the morning, the entire day I will not be able to give my best output.
Right, absolutely,
Right?
absolutely.
So with the recent debate, no, people say you should have long working hours and all. There should be a parity. Health
Absolutely,
should not be compromised.
absolutely,
Right?
absolutely.
Okay. I just wanted, because sleep is a very fundamental aspect of our lifestyle. So you don't do away with it.
Right, absolutely.
But to what proportion should we take it? I'm coming to another aspect of it.
Yeah,
Some people say, no, I need 8 hours of sleep. And some say, okay, 4 hours of sleep is good enough with me. No, there's always been a debate. Sure, if you are having 4 hours is more than enough. And there are also people who believe that 8 hours is a minimum. So is there any evidence that you need 8 hours of sleep?
I think on average that's true. Oh, on average, for most people, that is certainly true. There are individual differences. Um, But, I'd say 4 hours is probably on the extreme end. And the people, so many times what people have seen is that, you may think you're fine with 4 hours of sleep, but if you come into a lab and you do all these cognitive tests and so on, many times you think you actually turn out to be more impaired than you think you are. Okay. And even for the people who think, oh, I'm doing fine with 4 hours of sleep, maybe you do even better if you had more sleep.
Oh,
Right? Uh, so you should try it.
yes, sir. Never slay.
It's a big,
Right.
you should explore that. Is
When I travel extensively, even I feel like I need some 1 day sleep. And when I get that break, then I think, now I'm back on track. Yeah, right. So initially, we think we started with one terminology called sleep inertia. So if you said sleep inertia is something different from this category, like I'm carrying over my dizziness, I wake up in the morning and I'm not able to get rid of my drowsiness or the.
right, exactly. So
Is this a common thing, or is it an underlying physical problem?
yeah, it's probably some underlying physiological problem exactly not very well understood yet. As to what generates this inertia and how does one overcome it. I think it's still not like clear yet. Yeah.
Right.
But that's a very interesting question.
Yeah, just
Yeah, try to, there are interesting things, it's very, it's something that affects so many aspects of brain and body, right? So that's why it's, I think so.
In this, I said, I have one, like, we have a common myth, or not a myth, rather. Actually, our parents had been telling early to bed, early to rise, makes a man healthy, will, right? Is it true?
No, probably not. But, it depends on something called a chronotype. So people have different chronotypes. Um, and so chronotype is essentially, you are, have a time of day when you prefer to go to bed and time of day when you prefer to wake up. So some people, so by and large, people would sleep between, I don't know, say, you know, 11 p.m. and 7 a.m. or something. That's probably hasn't true, but there's clearly exceptions. So it's a normal distribution. There's people who are early chronotypes, and I'm not supposed to sleep really early. They're supposed to sleep at 9 o'clock or something, and then wake up at 5 in the morning, something like that, 4 o'clock, something. Right? Whereas I'm more of a late chronotype, so I tend to go to bed later and wake up later. And so it's important, I think, to adjust your, if you could, adjust your work schedule, to match your chronotype.
Okay.
This is not always possible because the world doesn't always operate this way. There are many things that have to go on. There are many moving parts in a society, right? So you can't always, it's not just a question of when you go to work, but there's other things. There's, there will be a caretaker for the children and so on and so forth, right? Everything to coordinate and so on. Getting your children to school or time school bus has to come at a certain time and all of that. So it's difficult, it's difficult. Yeah. But is, ideally, we would like to match as much as possible.
I have another observation. So when we were in a family, like kids going to school, so usually our parents used to have a 9 to 5 jobs, so they have to wake up at a particular time, and then dinner time is also fixed, so go to bed at a particular time.
Right,
The moment we stepped out of our home, we came to hostels. In hostel culture, you have late night study culture.
right.
So because that is the most peaceful time of the entire 24 hours. So you get your time, you work and you sleep maybe 2 or 3 a.m. And next day morning you wake up and hurriedly brush up, take a shower, and then go to college.
Right.
So then your paradigm has shifted.
Absolutely.
You have become more of a nocturnal, and your entire routine has changed.
Right.
And this college period is, some people like 5 years, 6 years, a little more. Like PhD guys, it is even more.
Right. Right.
And gradually, what happened, that has become a norm.
Right.
So when we say, okay, our parents used to say, early to bed and early to rise, we used to say, okay, if that was true, then we would have terribly failed, or our IQ would have terribly gone bad.
Right.
If we are, waking up late in the night and studying for exams.
That's true.
Right?
That's true. It's true, but while the topic of college and studying for exams and so on, a lot of people tend to students have to cram the night before. I mean, that's really not great, right? So try to space it out as much as possible, so that you don't, get a good night's sleep well rested before your big test or something.
Yeah, that says my observation about sleep, how our life automatically changed.
Yeah,
Knowing you, unknowingly.
it's true. Absolutely, it's true. Although I have to say, my roommate in college and I had opposite schedules. I was more of a day night person always, and my roommate was very much an early to bed, early to rise kind of guy. So, people are different. So he struggled more than me to adjust to hostel life. Uh, but yeah, it's true. I mean, I think when you're young, it's a little bit easier because your body's a little bit more adjustable and so on. Um, but
Yeah,
I totally,
as you age,
yeah,
I think the plasticity also is gradually decreasing.
yeah,
That is
the
that is coming to the I mean the plasticity when I landed on this world. So as we age, obviously our brain plasticity decreases. Our sleep is also a part of this entire thing, and that is why elderly people have less sleep compared to youngsters.
right. So that's a good question. I can bring up. Why is it that you have sleep disruptions with age and so on is related to particular sleep promoting arousal promoting areas in the brain and so on. And you see, degenerations in, some parts, in promoting areas, things like that. Um, you know, but this is also true in other animals, for example, even in flies, the age flies, have sleep impairments and so on. Uh, and it can certainly exacerbate, other problems with aging and things like that. Um,
Right, right. So we have seen that's like usually elderly people have trouble sleeping
right,
and they, literally find different ways, maybe their comfort zone, maybe the bed.
right, exactly. It's what China's the sleep opportunities section for sure. So, for example, we had previously shown that age flies are impaired in spatial learning tasks. Um, so it's similar to humans. For example, in humans, you know, aged people tend to have problems, particularly in the class of memories called declarative memories. These are memories, episodes and facts and so on. And there is spatial learning is some kind of evolution precursor for that. And so also flies also show impairments in this spatial learning. The interesting things to enhance their sleep, um, they get better.
Oh,
Right? Yeah. So it's not happening enhance the sleep throughout their life, it enhances the sleep after they have aged, right? So then sleep is able to reopen this plasticity, right? Somehow make the brain more plastic, and help us restore some of these cognitive impairments and so on. Uh,
so sleep therapy maybe for Parkinson's or no, those patients to some extent are not being
yeah, no,
too tall a claim.
yeah, no, not at all. But so particularly Parkinson's a little bit too, but certainly for Alzheimer's, this is actually very, very strong. So, for example, we know with multiple kinds of system, multiple animal models and so on, that as sleep disturbance is one of the earliest biomarkers for Alzheimer's disease. Um, so we start seeing sleep. So this is much before we start seeing pathology in the brain, much before we start seeing other kinds of cognitive impairments. And it kind of becomes a kind of vicious cycle. So you have sleep disruptions because in Alzheimer's disease, the Parkinson's too, disease is a protein aggregation. So you start forming these kinds of protein aggregates in the brain, um, and the aggregates start sleep. Sleep increases sleep loss increases the aggregation and becomes a cycle, right? So you lose sleep, get more aggregates leads to more seed loss, which then leads to more aggregates and so on, right? And so, at least in our models now, there's pretty good data that suggests that you can actually, if you intervene by enhancing sleep, okay, um, uh, so you can do this a couple ways. You can do this by genetically. You can do it by feeding drugs and so on, pharmacologically and so on, or by sleep optional restriction. Right? You can break sort of the cycle, right? So that you don't you can actually mitigate many of these cognitive impairments and physiological impairments associated with Alzheimer's disease and so on. A little bit of this book in Parkinson's too, but the evidence for Alzheimer's is very, very strong.
So what we think sleep is, it has a lot more to understand.
It has a lot to understand. Yes, yeah, absolutely. So I think, there's several ways in which the field is going. One of which is, for example, this idea that, enhancing sleep reopens its plasticity, which is the brain more plastic. So it's not simply um, consolidating. So that there's a very vast, and we talked a lot about this, is the established role of consolidating a very healthy brain. But again, this idea that if you enhance sleep, you can restore function into an impaired brain is really pretty interesting, I think. So, but we haven't actually changed the genetics of the animal. I think just somehow change the plasticity in the brain in a very interesting way. Oh,
Okay. And in this context, I was reading somewhere like our left portion of the brain controls the right side and the right portion of the brain controls the left side. So if you have to, and one side controls the emotion, other side the analogy or the thinking part. So if you have to inspire somebody, emotionally, right? So then you have to tell that person on the left ear Is this
A little less, a little
to exaggerate?
a little too exaggerated. They both do all of those things that you talked about. Some are slightly more on one side versus the other, but it's a little.
Okay, and then I was just going through. I just wanted to know. Yeah, understand. Is it true then? So the person who there was one podcast I was listening, and he was saying that when you're talking to a child, you should be, if you are emotionally talking, then you should be, going to the left ear.
He says it's too far best, little too far fast. Yeah.
Upset, we would like to understand what actually excited you and then how you got driven into the sleep research area.
Right. That's a great question. So I came to sleep research from an interest in plasticity and learning. And so I had this long-standing interest in trying to understand so from very basic science, trying to understand how does the nervous system generate these behaviors, and then how does experience and so on, uh, modulate, uh, uh, modulate circuits, right, to then change behavior, right? Um, and the eternal theory, how does that play into all of this, right? And so sleep, of course, is speaks to all of these things. Um, and I had a little bit of time towards the end of my postdoc to really think about what I wanted to do with science. And at that time, I kind of started the field a little bit, and really found that it was field research is a very exciting area. It seems to be as broader questions I was interested in of how space changes circuits and how the internal state modifies that and so on. Um, and And of course, there's a lot of, has great clinical relevance, which is always a good thing. And and really, there are many different, it speaks to so many aspects of the brain and body that there's many avenues to explore. Okay? So many fields in science are very mature, and for example, particularly in physics and so on, right? The fields are very mature, so the questions tend to be extremely detailed. Whereas I think something like sleep research is so much risk up, right? There's so much risk up. That was really exciting for me. As why animals, I think, for example, we work largely with a software, uh, fruit fly. And so these are, I think, a great model because Flash for example, has a lot of parallels with you sleep. You may not necessarily.
Yes, I want to come into that, because flies sleeping. How did you, found your interest in that, and how is similarity of the patterns of the sleep in the flies versus in the humans?
Absolutely. So some second part. So actually, it turns out they have a lot of parallels, which might be somewhat surprising to people. So, so flies sink through the night like we do, by and large. So the longest bout of sleep is about 4 hours for a fly at night. That's pretty good. Um, and the seems also modulated in many of the similar kinds of ways. Like for humans, for example, we are talking about aging. So, for example, baby flies also sleep a lot, like humans. And they show aged flies, for example, don't seem so well. Many of the kind of pharmacological compounds modulate sleep in humans also modulate in flies. For example, caffeine will keep fly awake. Uh, and histamines make us drowsy, and so on. Many of the same kinds of neuromodulators modulate sleep in humans, wake in humans also modulate same similar in flies. For example, GABA, which is something that a lot of people may have heard of. Is about the sleep morning. It casts the directions and flies. Dopamine or promotoplasm, it flies in humans and so on. Right. And of course, from functional aspect as well. So, for example, a lot of studies have shown that, now work has shown that if you're restricted by flies, they don't build so well, so on. So it has similar kinds of functional outcomes as in humans, um, and they also show same status like we do. So again, they have a kind of a quiet simple state and an active simple state.
Mm. Oh, but maybe a very basic way of understanding is how do you understand when flies are sleeping?
Right, exactly. That's a great question. So, remember, suppose back to the criteria I told you earlier, we use these behavioral criteria.
Okay.
So, again, we know that, so they have these some criteria, they have to be mobile for a period of time. Right? The ability has to be reversible. Uh, it's associated with the horizontal thresholds, it beats the horizontal thresholds, it's most accurate. And so this is true of flies network. And so how we measure it, we actually have this activity monitor. So it's middle device, not very complicated. And you have these different, if you're being in the middle, you put a fly individually in these little glass tubes. Okay. The fly will walk up and down the length of these tubes. And every time it crosses this, this, like I said, it was infrared beam in the middle. Every time it crosses the beam, it will blip. You see, the fly is active. And a lot of foundational work in the field had shown um, that uh, that about 5 minutes of inactivity meets many of these criteria for sleep. So, for example, if a fly is inactive for at least 5 minutes, it will show change in what's called these ROS thresholds, which is a defining trait of sleep, as we talked about earlier. So, you just look for stretches of 5 or more minutes of inactivity, and you will fly sleep. Okay. That's interesting. So, say high throughput. So, for example, in our lab, we can record sleep of like 2,500 flies at a time. What? Yeah. Wow. And on each fly, you have one capillary or one tube. Huh? So, wow, that's amazing. Yeah. Yeah. It's really high throughput. It's great.
Wow.
Yeah.
Okay. And then, yeah, so then you see the patterns of their falling asleep and coming activity. What is the pattern for each? Oh, that's amazing.
Yeah.
So, because, for most of the, even for me, I who are already hearing this podcast, for the most, it will be something very new.
Right, exactly. So if I say the flies are vibing and prayers, right? The patterns are very much similar to how humans do, is it? It's really amazing to keep careful. Revolution in person one is it does that. So keep losing the same kinds, the more to lose again and again. Yeah.
Absolutely.
Yeah.
So now once you've understood the patterns and all, then you give some, let's suppose you want to induce certain things. You do them give them stimuli early,
Yeah.
or the light effects, how do you monitor or alter their behavior to see the response against that?
That's great. That's a great question. So, like I said, we have ways of monitoring the sleep. For example, we can femtilize the stars, monitor the velocities, we can sleep. We can genetically also activate or activate neurons, including the light. So, this is something called optogenetics, which very people heard about in compounds and so on. We can genetically express a channel in the different neurons. It's a light activated channel, and based on the kind of the properties of this channel, you can either activate or leave neurons. So that's how we're to modulate sleep awake. I use the opportunities and light.
Right. I think the other day also when we were discussing about imaging the brain, if there's an activity, neurons will start firing and that can be captured.
Right, absolutely. So absolutely. So let's be really excited about the microscopy facility. For that ability to do that, to record from neurons.
I have not come across of any applications of microscopy related to this. It a lot of Drosophila images and all related to larva and to that and brain, eye compound eye. We do a lot of maybe for the resolution purpose. We do the ommidria images and the blindness. How no, once this is blind eye, now the recovery is happening. Yes, master certain was so those cities are from because that is something
Yeah, we was really excited to try, doing a lot more than microscopy to figure out, how activity patterns of neurons change when sleep and wake as the passage wakes up. And
and challenging part is because if you do it usually in intravital imaging, we do it for animal models.
right,
So where animal skull is drilled open, right? Then you have the probes and video physiological experiments.
right,
The brain is considerably big. Right? It's easy to fold it. The only challenge what you see this with the fly which is so small, it's tiny. You have to be very careful to
versus school.
tiny. Yeah, say them very precisely.
Yeah,
To design it.
yeah, absolutely, absolutely capture it. So we have a
But I'm sure we'd be able to come to a certain way of utilizing certain things.
fly can be blended, absolutely. It's really amazing. Yeah, absolutely. We're really, really excited for it. So
we faithfully be a mass collaborators who've been very sweet and who've given us designs for something they call this pyramid, which is a kind of a custom made slide that you can glue onto a fly's head. Uh, and so you're glued in the money. They're very careful with it and so on. But it's book. Yes, it's nice. So you're collaborating in India or abroad where you sit as that with in the US Navy, but yeah. Yeah. Coming with it, a different question maybe. In this we are going with one flow. So I just want to understand your other perspective of it. So usually when people are into neuroscience, they want to understand the brain and the functionality. Common trend is go to study human brains with functional MRIs and all the ways neurons are signaling everywhere, the mapping has to be very nice. And people are mostly into it. Apart from there, you had taken over to a different direction to so mapping a fly brain map, like fly brain. Yeah. So, like, how do you see this? Yeah. So I think the is it's in so to me, I think that the exciting thing about the fly is the level of detail you can get. Right? Which, for example, with fMRI, because you just reference fMRI, but every little box of an fMRI is meant as bigger than an entire flag. Yeah? So what you're catching with fMRI is a kind of an ensemble activity for a very large number of neurons. Right? Uh, and they're fine because that's what you can do. But in the fly, we have ability to look at a single neurons at very high level of detail. So look at activity of single neurons, but also look at how the structures change and so on. And this is possible. It's much easier to do in fly, than pretty much any other synapse one. Um, and the other big thing in fly neuroscience uh, is a really fantastic tool that just came on board maybe last year two. Is something about the connector. So connectome is a highly detailed map, synaptic level map of connections in the brain. And so now we have this for one, well, we have one for one fly. But it's a map. So it gives you this map of what's what and how strong we are connected and so on. And having this map is fantastic because it lets you build much more everything to target experiments than what we do for others. So I just curious, how do you connect these signals, or what is the device there in the Angular? So the connectome was generated by people doing neurodegeneration to make a block of a bit of and the brain in a block and it was also a block, yeah. So they collaborated sessions like this have and then like you those sessions and then the way the actual techniques of art is not terribly hard. Cutting sessions, viewing sessions. Obviously was not so much. So they block face image that right. So that part is not so hard. So the very hard part has to assemble all that information into tracing the neurons, figuring out which is where one neuron ends, the other neuron begins, where is the synapse and all that. That's very hard. Really hard for us to use processing. Sir, coming to that, it was nowadays the integration of AI. But also, I guess us coming to that. And you said with the ZICE system, what we have a AI version along with it. So where that can take a single sensor information, give you a 3D constructed in all the neurons. It absolutely as possible. Absolutely. So this effort of the flag connector was a really unique collaboration between university and Google, CBI. So they used AI, but they also had they being as involved as Song and Moti. They had a kind of a fun way to have human validation of some of these things, which was to make it into a kind of gig. Mm. So it has something we call an eye wire, which was better for the retina, and then they kind of modified that to the fly wire for the fly brain. But it was a game where people would play, and you win by
I'm taking neurons instead of playing a video game. So that actually there was a lot of human narration involved as well. So I was totally wrong. So we're talking about this to make sure. So but I didn't have wrong. This season was the previous season was a shot and there was one product. So there's a students who have dyslexia maybe or learning capabilities compromised. Right. For them, it's simple version of a EEG. Right. Just put it and there in the tab there's a game, puzzle game. So they know that they're doing some games. When they do it, they coordinate that the brains are actually coordinating efficiently or not. The statistics part is and then they're scoring the functionality of the brain based on the this. Right. Yeah, this sounds cool. So when I saw that, they said, no, this will help you because most of the children in the brain stage they are not able to express their problems. So they said, no, we don't tell them to do this task. We just say to play this game. Right, absolutely. Absolutely, yeah. It's a simple but a very nice way of coming up with that analogy. I don't know what is actually trying to be going on. And with parents who usually they know that he's not interested in studies, so he's doing all this. It maybe has his son are actually the problem. Right. Yeah. Yeah. That's true. You're right. Yeah. So I think microscope is one segment which is like about evolving. Yeah, absolutely. I have used the way you have been thinking to go ahead with such a lot. Microscope is very bit about last the absolutely very super excited to try out things that is nice so it's something really kick our science to go to the next level, which is good. Yeah. Very good. If the AI is still on the hang of get a 3D model, you get a very well step to physical slowly. Yeah. I'm looking forward to it. Yeah, it's super excited. Two levels, the one level that I understand physiology, that's how therapeutic paradigms change. Um, but also the structure we try to understand the structures of change and the sort of also really helpful for the structure part. The non-important for the engineering part, the physiology part. Yeah. Yeah. So I think instead of a sea of light, I will have different thought. They do pretty amazing things. Yeah, small race can do amazing things. Yeah, yeah. Saturday days that is okay, and I got a lot of new and very very fresh and different perspective about sleep. Yeah, and that's how we criticize yes, yes, not only sick, but also on the fly life as well. Yes, right. So it was absolute pleasure and an honor to have you on our this back on our talk. This is really fun. Thank you for that. Thank you for the opportunity. Yeah.